I'm the PhD student leading this project, and today we're out here catching chinook to bring back to shore and use in our holding study. We're fishing with 2 other vessels. Their main objective is to catch fish for us. Taking all metrics of the angling event, how long was the fish fought for, how deep, where was it hooked, is it bleeding, taking all these metrics, and then they're transferring the fish to our boat where we're doing a further assessment and then eventually taking them back to Bamfield Marine Sciences Center. Well, I've grown up fishing my whole life, just been obsessed with it since I was young, and I was really lucky as a kid. I had the opportunities with my family to go out and try fishing and just fell in love with it. And when I was doing my undergrad at UBC, I met Scott and was chatting with him about fish, and I eventually just volunteered in the lab and learned about this project and had to be involved. So this is technically my 3rd year in Bamfield. My first 2 years I was doing a tagging project where we'd tag chinook in Barkley Sound in August, and then I would track them from Barkley Sound up through Alberni Inlet, Somas, up to Stamp, and up to Robertson Creek Hatchery. So looking at impacts of catch and release, how they transfer from the ocean to the freshwater environment and through spawning migrations. And then last year I started a holding study with the Sport Fishing Institute of BC, and that's a 2-year study, so this is year 2 of that study, and this is more so looking at the short-term survival, so the first 2 weeks after you release this fish. We're holding them in tanks so we can watch them really closely, see how things progress, and that kind of fills in the gap that we have in our tagging work, because in our tagging work, when you tag a fish and let it go, you don't really know what's happening in that first 2 weeks.
I'm Scott Hinch. I'm a professor at the University of British Columbia. I run the Salmon Ecology and Conservation Laboratory. We do all sorts of different things in the lab dealing with salmon migrations and salmon physiology. Recently, we've been doing a lot of work on catch and release fishing and looking at the potential impacts of release and looking at finding solutions to improving release practices so that we can have more fish survive to get to spawning grounds if they are released.
Well, we're not looking for the same fish everyone else normally is, but yeah, we managed to get 32 yesterday on shore in the tanks. So we're studying catch and release mortality, so basically any fish that people aren't looking to keep, so anything from 30 centimeters all the way up to as large as we can find. But so basically your traditional shakers. We're happy with those fish for our study because most people are releasing them. So we've got partner boats here. They're working with us, angling with us. We've got students on board their boats as well, recording any kind of capture data. They'll take the fish, do a very quick assessment on board their boat, and then actually put it in a recovery bag like they use in hatchery systems, and attach a buoy to it, and then they'll float that buoy, and we'll come by as we're trolling or just as we're picking up fish, and we'll pick those up and bring them on board as well. Peduncle looks good. Fins 622. Scale loss is a 0. Eyes look good. Got a chin miss injury.
When we tag fish, we're limited by how big the fish has to be able to carry the load of the tag. So in this case, we can actually assess these smaller fish kind of for the first time, which is really useful information because these smaller fish are released the most. So it's really important we understand what happens to these smaller bodied fish as well.
Scale loss of a 1. Hook wound of a 1. Looks probably like it was in the corner. Fins 622. In the scoring system we use, we just look at the various injuries and grade them. So a 0 being no injury present, compared to a 3 where we've got like a severe bleed or really an entirely ruptured eye. Like this one here, you can see has an eye injury score of a 2. So there's still structure to the eye, but you can see it's fully pooled with blood, and so likely non-functional anymore. But there still is structure, and It's not fully enucleated, so there's potential that it can recover. We're running home, putting the fish in the shore tanks. Legs in 5 different directions.
I get one more.
Yeah, I caught some balls.
Just gonna make sure
This is an example of a fish that we got from another boat. You can see that the eye is quite damaged here. It's filled with blood. There's some tissue damage around it. It's likely that the other boat didn't see any blood pooled in the eye, which is why we take this measurement 2 points in time. Right when the fish is caught, we look at the eyes, and then when we get it on this boat and look at it again, we take a second look. And what we've learned is that, you know, in that 5 minutes, the eyes do pool up with blood. So even though you may not see that injury as an angler, there still can be a sneaky eye injury, kind of the eye gets poked from the inside of the mouth, and it actually does impact the fish. So that's one of our findings. Just, you know, it might not be an obvious eye injury, but it does happen quite often. When the fish is moving over, you can see that both eyes are rolling, so it still has muscular control, but as you can see, it is pooling with blood, so there definitely is some more internal damage. And that usually comes from hooks going in the roof of the mouth and then poking the back of the eye. The eye injury, just for a fish, it takes away one of its senses. It can get, it doesn't see predators coming on that one side, and it's just a really vital organ for them. For any scale loss on the caudal peduncle or the wrist, we take note of, if our handling's removing scales there, because that's often associated with how people hold the fish when they take photos, and we notice that scales are lost there when we're handling the fish, so we record that. It's looking at how many fins are damaged and how severely they're damaged. Look here at the fish, you can see that there is a tear in the pec fin. This is due to being in the net. In our other research, we've captured fish without putting them in a net at all, and you'll notice that the fins virtually have no splits in them whatsoever. Whereas where they touch a net, it definitely slices their fins. These wounds on the fins, they don't seem to heal with time, because we've recaptured fish we've tagged in fresh water after being captured in the ocean, and these fins do not heal. So now I'm gonna put a pit tag in the fish. This is ultimately a way that we tell the fish apart, because they're all being put into a tank together. We need to be able to link the information for each fish back to the capture event. Next, I take a swab of the mucus on the fish. With this sample, we send it to the lab and look for any infectious agents in the sample. This is kind of a new method. People haven't really done this in the past, but if we are successful, it's a really non-invasive way to get an idea of what infectious agents are on the outside of the fish. The other way we assess that is we take a little clip of the gills. So as you can see, that's a little bit more invasive. This always heals in the fish. When I check them again in 2 weeks, where we took the gill clip, it's all healed up and good to go. With this gill clip, we look for infectious agents, and we can also look for genomic biomarkers. So what genes are turned on in the fish? Are they thermally stressed, just stressed in general? Those kinds of things are what we can look for with that sample. And then the last thing we do is we take an energy probe reading. This tells us the general fat content of the fish. So my readings were 0.3 and 0.3, which is what we'd expect from a young fish like this one that's still eating and growing, not really going back to the river yet.
So this is called an energy meter. We call it a fat meter for short. It's used in the aquaculture industry to grade fish prior to selling them and knowing whether or not they're ready to be sold. We've been using this tool for about the last 20 years in our research program to look at fat concentrations of fish as part of their homeward migration. It's also turned out to be really useful in some cases for stock identification because different stocks have different levels of fat. So our collaboration with the SFI has been fantastic. We like to work with various stakeholder and user groups because the research then is much more practical and it's more readily taken up in terms of the results when we work with partner groups who are interested in this sort of research. Frankly, we couldn't do the work without partnering with different groups just because of the cost and logistics of what's involved. And so working with the SFI, for example, has been a really great experience for my lab. And I think we're both learning a lot from each other. And working together, we're going to be able to develop some really good best management practices for catch and release.
Lively. A lot of fish, whether it's due to regulation or choice, species, slot size, whatever it is, a lot of fish are being released. And the assumption of this fishery is that fish that are released survive. But there's a lot of things that impact the survival of these fish when we let them go, and we know for a fact that they don't all survive. So we're trying to better understand what gear types and methods we can use to increase this opportunity for them to survive, and just really understand what's truly happening to these fish.